and welcome back. This is part 2 to a video I made a long time ago, and basically just getting some desire, motivation to continue on with it, and also priorities as well too. So in my first video I basically laid out what the issue is with this oscilloscope. This is an old HP. I got this pre-internet and pre-eBay. I believe this was on a submarine, and I do have a problem with it right now, but prior it was operational, and I liked the way it worked. You know, so much more so that I have a Tektronix digital, and I just like the analog for RF so much better. So that's another reason for me to get this guy operational. Luckily, I have a complete service manual on this, and I do have schematics as well too. And we can see here I just have the section here. This is for driving the CRT deflection, the horizontal, and I have used the multimeter here to try and track down where the issue is. So I have made some measurements. Before I get into that, let me just review and show you what the problem I have is right now. Let me just turn this around. I'm going to need both my hands because this sucker's probably 50 pounds. So let me just turn this guy around here and I'll show you what the issue is. Okay, we got the old girl warmed up. I'm not sure if you can see that there. There's a model USM-281. Okay, I have a calibrated signal on there. Let me just show you. I've got the vertical here. The vertical works. But as we can see here, that here's where my signal is starting. And I've got 3/4 of a screen here where my horizontal position does not function. So that, again, in a nutshell, is the issue, the horizontal deflection. There's my service book. Lots of information there. January 69. Also have a PDF on this as well too. So it's a 50 megahertz. So good enough for HF work. And that's basically my intention. So back to my schematic here. Let me just point out some of my findings here. So I've measured, just using a DMM, and I have found that basically we've got a plus and a minus. So this is the minus, drive, and this is a plus. So when I fiddle that horizontal control that I just showed you, I get 28 to 74 volts. So I do get this whole section here doing what it's supposed to be doing. When I come over and try and get the other section to operate, I'm not getting those voltages. So I focused my energies on this section here, and what I have discovered so far is that I'm supposed to get minus 0.1 volt here, and I do not. So even though I am just a hobbyist and I'm not a professional, lacking experience, I have found that what's beneficial in this case here is that I have another section here that's practically a duplicate of the faulty one. So that has helped in the troubleshooting. I do have this section here is operational. It's doing its job. So what I've done is, I've taken values up here, and then I can transpose them and try and figure out what's not happening down here. This schematic is actually pretty good because it does list as well what voltages should be where. So as I have just noted that I'm getting minus 5 volts here, and over here on the emitter I'm getting a 0.42 when it should be 0.5. So I'm getting a 0.7 diode drop here between these 2 points. So that's a good sign. I do have the proper voltage up here. I'm just getting the wrong input voltage on this transistor. So I am not sure if this transistor is faulty and not able to drive the output, or if it's the input signal. I've measured here, I'm getting these voltages, so I'm still not totally sure what to do. So I think what I'm going to do here, I can't check this transistor in place. I tried. I've got my tester here, very handy, reliable, but when I hooked it up, and there is the board in question, and the transistor in question is this guy right here. All discrete components, easy to work on, easy access. And of course, if anybody else is working on such a unit, be wary that there are high voltages within, and proper precautions are needed when you're dealing with high voltages for your personal safety, along with your test equipment. Because these DMM, they'll handle up to 1,000 volts if you're lucky. But within the unit here, I think there's 2,500, 3,000 volts, so they can cause a lot of damage in many ways, so be cautious. So right now I have it unplugged, but of course, that's a tube there like a capacitor. There's still going to be voltages present, so one still needs to be cautious. So what my plans are to, I want to, and that's also the benefit to documenting this with a video is that if something goes wrong or I forget, one can come back here and check. So what I want to do is take this board off and take that transistor off and check them out as my next step. So here is the this board is broken into the, kind of draw a line in between here, and here's the one section which is the bottom of the schematic, and here is the other section. So yes, as I was saying, what I want to do is I've got these, take the board off. I've got these connector pins here. I want to mark these. Because that's another reason why I was putting this project off, was I didn't want to do that. There's lots of pins, lots of little wires there. And I was contemplating whether or not to continue on with this video or put this on a part 3. Thinking what I'm going to do is put this on a part 3, and hopefully this will come out in a better time frame than the part 2 did. Stay tuned. See ya.